Hi there, John here, and I want to welcome you to an InventorCAM Professor video series geared to get you started with iMachining. Now, if you're looking for the help you need to get up and running with iMachining, then you've come to the right place. In this Getting Started series called Exercise Number 1, iMachining Walkthrough, I'll show you how to quickly and easily program a simple part step by step using InventorCAM's iMachining technology. Now, this exercise is designed to show you the minimum requirements needed to define an iMachining operation to get you up and running as soon as possible. All right, let's get started. If you don't already have Autodesk Inventor opened, go ahead and launch the application. After you have Inventor ready to go, you'll then have to open the part that's provided with this series of videos. The part file called IVIM Walkthrough can be opened directly from our Getting Started interactive guide. If you're otherwise viewing these videos from the InventorCAM website, you should have downloaded the part file and saved it to your computer in a preferred location. After you have it downloaded and saved, go to the Get Started tab of the Autodesk Inventor ribbon and click Open. From the Open dialog box, browse to the file location and open it. If you're not using the interactive guide, this is how you'll want to open the provided part file. I'll wait a minute until you're ready. Alright, now that we're ready, let's make sure that we have our CAM settings customized for these upcoming iMachining Getting Started videos. Go to the InventorCAM 2015 tab of the Autodesk Inventor ribbon and click CAM Settings. InventorCAM will start and display the InventorCAM Settings dialog box. As you probably know, this dialog box enables you to change things like the path to related directories, units, tolerances, default machines, editors, and even color settings. The first thing that we should take a look at is the automatic CAMPart definition and its related default settings. So go ahead and click Automatic CAMPart Definition in the list and just make sure that Definition of CNC Controller, Definition of Coordsys, Definition of Stock, and Definition of Target are all deselected. These options being disabled will help you become more familiar with the CAMPart definition process, which is an important step when using InventorCAM and iMachining. So let's now go to Default CNC Controller in the list. When you click the drop-down under Milling CNC Controller, a list of post-processors currently installed on your system is displayed. Let's choose the G-Milling Post for a 3-axis Haas SS. This will be the CNC machine definition for all our iMachining examples moving forward, so it's actually good that we're making it the default selection now. Let's now click OK to accept the default CAM settings and close the dialog box. So now here we have our CAD model ready to go into InventorCAM for programming. For our first step, of course, we have to create and define the CAM part. To do that, again, go to the Autodesk Inventor ribbon. In the first command panel of the InventorCAM 2015 tab, click New, Milling. When the New Milling Part dialog box opens, simply click OK to use the default settings to create the CAM part. As we know, it'll be saved in the model file directory. Next, the Milling Part Data dialog box is displayed. This is where we'll define the CAM part, not just for the general use of InventorCAM, but also specifically for iMachining. First and foremost, we can see that our default controller selection is already defined so that we can post G-code for a 3-axis Haas SS. Next, click the Define button in the Coordinate System section to define the origin for all the iMachining operations of this CAM part. Using the default Select Face option, click on the top face of the target model to position the coordinate system in the graphics window with the Z-axis normal to that face. Then I want you to click the Pick Origin button and pick on the back left corner of the stock model to place the coordinate system there. Click Finish to accept the selection and close the Coordsys dialog box. When the Coordsys data window appears, click OK to accept the default machining levels. To confirm the coordinate system definition, Mach 1, Position 1, click Finish in the Coordsys Manager. Moving down to the next section, we have to define the stock and target models. To start the stock model definition, click the Stock button. When the Model dialog box appears, click the drop-down in the Defined By section and choose 3D Model from the list. Now, since there is a solid body representing our stock material, we can use this option. Now, like I've done here, I would recommend modeling your stock ahead of time in Autodesk Inventor before you bring your CAD model into InventorCAM for programming. We do, however, have several options for defining your stock material without a 3D model actually being present. So, if you don't model your stock ahead of time, don't worry. You can define it by another method. Now just pick on the stock model in the graphics window. You'll see that Solid 1 appears in the list, confirming that our stock model is defined. Click Finish to accept the stock model definition. Next, click the Target button to define the target model. When the Model dialog box appears, simply pick on the target model like so. Again, Solid 1 appears in the list. The target model is now defined, and we can click Finish to accept. So that completes the CAMPart definition for use in InventorCAM. But if we want to use the iMachining technology, we have to define the machine and work material parameters. And we can do that right here in the iMachining data section of the Milling Part Data dialog box. If for whatever reason you don't make these selections now in the CAMPart definition, InventorCAM will prompt you to make them when adding your very first iMachining operation. I'll likely show you this in our next exercise. Now, in order to use the iMachining technology, you have to inform InventorCAM of two more very important things: the machine you'll be cutting on and the type of material that you'll be cutting. For the purpose of this exercise, click the drop-down under Machine Database and choose Haas SS from the list. This machine database file is included with the installation of InventorCAM. Next, click the drop-down under Material Database. You'll see that there are many materials supplied with the system. For this exercise, I want you to choose from the list aluminum with a 100 Brinell hardness number and a hardness Rockwell of 60 on the B scale. Leave the machine default level at 3 for now. Lastly, the Edit iMachining Database button enables you to add new and edit existing files in the iMachining database. I'll get into the specifics of using this button in the next exercise when I show you how to define new database files and input the required parameters that are used by the iMachining technology. At this point, the CAMPart is fully defined, and we can click Save and Exit to confirm the CAMPart definition. So that concludes step 1, where we've prepared our CAMPart for use with the iMachining technology in InventorCAM. In the next step, I'll show you how to add that very first iMachining operation and define the rough machining of the outside contour. A finishing operation will also be quickly defined.